How can I determine the measure of an inscribed angle? All right, let's define an inscribed angle. An inscribed angle has a vertex on the circle and intercepts an arc. An inscribed angle has a vertex on the circle and intercepts an arc. So if you got take a circle, angle. Angle ABC has a vertex on the circle. B is the vertex of the angle. It sits on the circle. And the angle intercepts arc AB. Arc AC. The measure of angle B is equal to 1/2 the measure of arc AC. So your inscribed angle is equal to half of its intercepted arc. So if this is 100 degrees, then the measure of angle B would equal 50 degrees. And vice versa. If you're given a diagram and you're given the angle measure, the inscribed angle measure of 17 degrees, then what is the measure of arc MO equal to? 17 times 2 is 34 degrees. All right, so this angle is going to be half as big as this arc. Conversely, this arc is going to be twice as big as this angle. Okay? So this would be 34 degrees. If I added another angle in here, if I added this blue angle, called it MPO, what is the measure of angle MPO equal to? 17 degrees as well, isn't it? Because it intercepts the same arc. It intercepts MO. So it's going to be half the measure of MO. If you added another angle, another inscribed angle, was this? This was 17 degrees. And the measure, MNOP, we'll call that Q. The measure of angle MQO would be equal to 17 degrees. So what can you say? What's the next rule going to be? What do you think it's going to be? If two angles intercept the same arc, then what? Then the angles are congruent. Good. If two angles intercept the same arc. Then the angles are congruent. And you just saw an example of that. Bottom of page 725. Angles of inscribed polygons. If an inscribed angle intercepts a diameter, then it forms a right triangle. If an inscribed angle intercepts a diameter, then it forms a right triangle. So here's what that picture would look like. You got a circle, and every circle has a diameter. What's the measure of arc AB here? 180, right? Half of the 360. Well, if an inscribed angle intercepts a diameter, your inscribed angle would look like this. Call this point C. Well, if arc AB is 180 degrees, then what is the measure of angle C? It's half of that 180, isn't it? Okay, so by rule, the measure of angle C is 90 degrees. So doesn't that make triangle ACB a right triangle? Okay. And if this angle down in here, angle A was X degrees, and angle B was 2X degrees, you could solve for X and find those angle measures, couldn't you? Because what do the three of those angles have to add up to? Yeah, the three of them have to add up to 180, and these two have to add up to 90 degrees, because the right angle is already 90. So 2x plus x, 3x, would have to equal 90. And if you divide by 3, your x is going to be equal to 30 degrees. And so the measure of angle A would be equal to 30 degrees. And the measure of angle B would be equal to 60 degrees. All right, that's an inscribed angle intercepting a diameter. It's going to form a right triangle every time. And page 726. Theorem 10.9. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. All right. Who remembers what supplementary means?
Isn't that like sum 180?
That a boy. They sum 180 degrees. Quadrilateral, what is that? Four-sided, very good. Four-sided. So you got a circle, and it's got a quadrilateral inscribed. So would look like that, right? Is that a quadrilateral inscribed? Nick? No, something's wrong there, isn't it? What's wrong with that picture? It's okay to talk.
It's not like the same size or equal.
The points are not equal to the side. Doesn't intercept a mark.
All the vertices need to touch the circle, don't they? So that doesn't work right there. In order for it to be inscribed, all the vertices got to touch the circle. So now it's inscribed. Because A, B, C, and D, the four vertices of the quadrilateral, sit on the circle. So angle A plus angle, what's opposite of angle A? C. Angle A plus angle C have to equal 180. And angle B plus angle D have to sum 180 degrees. Okay? Quadrilateral inscribed in a circle. Opposite angles are supplementary. Any questions?